Today we're going to talk about independent and dependent variables. Independent is talking about our x values or our input. We also talked about domain. Independent, domain, x, input, all of those are referring to our x values. Dependent is referring to our y values, our output, or our range. All of those words deal with y. Sometimes we'll have a graph, and instead of showing all four quadrants, it will just show quadrant 1. And whatever label is down here is the independent variable because this is the x-axis and we said x is independent. And on our vertical y-axis is the dependent variable. So these can change. It's not always going to be just x and y. It might say time and plant height or something like that. When we look at an equation, obviously we've already talked about that y is the dependent, but sometimes this letter will change. Whatever letter is by itself is dependent. And then this letter, which in this case is x, but it can change. The independent variable is where we plug things in, that input. We do not worry about the numbers at all. We're just talking about independent and dependent variables. So when we ask for the variables, we just want the letters. We don't want the numbers. We're also going to look at some situations and decide which variables are independent and dependent. The dependent depends on the independent. Another way to think about it is the independent happens first. We have to have that independent to be able to have the dependent. Dependent depends. So let's look at some examples. Here we have that first quadrant we talked about. Whatever is on the x-axis, month, is our independent variable. And whatever's on the y-axis, average number of tornadoes, that is our dependent variable. The tornadoes depend on the month. The amount of wall space and the amount of paint needed. Well, the paint depends on the wall. We have the wall first, and then we need the paint. So the wall is independent and the paint is dependent. Okay, the y is by itself, that's our dependent variable. X is our independent variable, not 8x, just x. Our independent variable is the one where we would put our input to plug in. The amount of snowfall and the length of time it takes to plow all of the streets. We have to have the snowfall first, and then the length of time it takes to plow depends on how much snow. Okay, again, whatever is on the x-axis, in this case grade level, is independent, and math score is dependent. The score depends on your grade. Z is our dependent because it's by itself, and W is our independent. The number of laps Craig can run in 1 hour and the speed at which Craig runs. Craig has to decide how fast he's running first, that's independent, and how many laps he runs depends on how fast he's going. Remember, independent has to happen first, and the dependent depends on it. Okay, another equation. Whatever is by itself is our dependent, and M is our independent. That is what we would plug into. Not 1/2 M, just M. The number of gifts and the number of rolls of wrapping paper. Well, we have the gifts first, and then we determine how much wrapping paper we need. The wrapping paper depends on the gifts. Age is independent. Height is dependent. Height depends on the age. the length of Beth's vacation, and the number of shirts Beth packs. Well, she's going to have her vacation planned, and then she's going to pack. She has to pack depending on how long she's going to be gone. She doesn't know how much to pack unless she knows how long she'll be gone. Again, the x-axis is always independent, so time and number of people is dependent. People depends on the time. I think I have one more. Amount of ink left in a pen and how long the pen lasts. Well, we need the ink first, and then the pen will last. How long the pen lasts depends on how much ink there is. Okay, the last thing we need to talk about today is what makes equations non-linear. So in our next unit, we're going to work a lot with lines, linear, but we need to be able to recognize it when they are non-linear. So linear means line. Notice linear has the word line in it. This is just any straight line. Non-linear is anything else. So it could be curved, it could be bent, it could be part of a curve. It could look a lot of different ways. As long as it is not a straight line, it is nonlinear. There are 5 things when we look at equations that make them nonlinear. Exponents with variables, so I might have x squared or x cubed. It could be y squared or y cubed or any exponent, but it has to be with a variable. It is okay, I'll put some things over here that are okay. It's okay to have a number with an exponent, just not a variable exponent. Variable in the denominator, remember the denominator is the bottom of a fraction, so if I have something over x or over y, that is a variable in the denominator. It is okay to have a fraction like 1/2 x. That x is not in the denominator, it's next to the fraction, that's okay. It's also okay to have x on top of a fraction, just not on the bottom. Absolute value of variables. Absolute value is when we have these lines on the side. Okay, again, that's just with variables. It's okay to have an absolute value of a number like 5. We just can't have an absolute value of a variable. Square root of variables. Square root is this symbol. Again, it's okay to have the square root of a number, just not a variable. And then the last one is x, y together. So I can't have x and y multiplying with each other. I might see an equation that has xy plus 5. That's not okay. X and y can't multiply together, or it creates something that is nonlinear.